Next, we are looking at exercises similar to the principal exercises, and we are busy with section 1.2 first. Number 62. It says prove that the norm of u plus v squared plus the norm of u minus v squared equals 2 times the norm of u squared plus 2 times the norm of v squared. Right, so what I'm going to do is I'm going to start with my left-hand side, which is the norm of u plus v squared plus the norm of u minus v squared. Then I'm going to write out what that equals. So the norm of u plus v squared is simply the dot product of u plus v with u plus v. And the norm of u minus v squared is simply the dot product of u minus v dot u minus v. Right? That's going to give us u dot u plus 2 u dot v plus v dot v plus u dot u plus, that's minus 2 u dot v plus v dot v. So this term cancels with this term, so we are left with 2 u dot u plus 2 v dot v. And u dot u is the same as 2 times the norm of u squared, and v dot v is the same as we have 2 times the norm of v squared. Number 68a asks us to show that if u is orthogonal to both v and w, then u is also orthogonal to v plus w. So firstly, if I know that u is orthogonal to both v and w, then I know that u dot v is 0 and u dot w is 0. So let's start with looking at u dot v plus w, because if I can show that this is 0, then u is also orthogonal to v plus w. So I know, based on the properties of the dot product, the distributive law holds. So I have u dot v plus u dot w. And I know that these two are both 0, so it's 0 plus 0. So our answer is 0. So therefore we've shown that u is orthogonal to the vector v plus w. Next we have number 46, and it says show that the plane 4x minus y minus z equals 6, and the line given by x equals t, y equals 1 plus 2t, and z equals 2 plus 3t intersect, and find the acute angle between them. Alright, so what we are going to do first is we want to show that they intersect. So all I'm going to do is I'm going to take my equation of the plane, which is 4x minus y minus z equals 6, and I'm going to substitute the parametric equations of the line into this general equation of the plane. So I have 4, and then x is t, so it's going to be 4t minus, then I have y, which is 1 plus 2t, and then I have minus z, which is 2 plus 3t, equals 6. So what I get then is 4t minus 1 minus 2t minus 2 minus 3t equals 6. So I'm going to have 4t minus 2t minus 3t, so that's minus t, minus 3 equals 6. So that means minus t equals 9. So that means that t equals minus 9. This means that the point where they intersect is when t equals minus 9 in the parametric equations of the line. So that means that x is going to equal minus 9 y is going to equal 1 plus 2 times minus 9, which is minus 17. And z is going to be 2 plus 3 times minus 9, which is going to give us minus 25. So the point of intersection is minus 9, minus 17, and minus 25. Next, they ask us to find the acute angle between this line and the plane. So if you are asked for the acute angle between the line and the plane, you are going to find the angle between the line and its orthogonal projection onto the plane. So let me just write that in here. So this is the angle between the line and its orthogonal projection onto the plane. So let's just look at what we have going on here. So I'm going to draw a 2D drawing of what we have. So this is our plane. Then we have a point A. That point A is where our line intersects our plane. And this point has coordinates, I'm just going to call it point A, minus 9, minus 17, minus 25. That's the coordinates that I worked out when I worked out where they intersect. So that's those coordinates. What I want to do now is I want to work out the angle between this line and its orthogonal projection onto the plane. So in other words, I want to work out this angle over here. All right. So what I'm going to do is, firstly, I'm just going to find another point on this line. I can find another point on this line by just setting t equal to anything in our parametric equations. So let's say I set t equal to 0. Then this x is going to be 0, y is just going to be 1, and z is going to be 2. So another point on the plane, sorry, not on the plane, on the line, is going to be b, which is 0, 1, 2. And I got that by setting t equal to 0. The next thing I'm going to do is I'm going to draw in a vector from A to B. And I'm going to call that vector v. Right. Now, I have some more information that I can use. I know that the equation of my line, of my plane, is 4x minus y minus z. That means that the normal vector of this plane is 4 minus 1 minus 1. Where did I get that? Well, it's just the coefficients of my x, y, and z. So, I know that I can draw a normal vector on this plane, anywhere on this plane, and this normal vector has components 4 minus 1 minus 1. So, if I can now firstly find the projection of v onto the normal vector, so in other words, this vector, and I can call it Tn, since it's going to be a scalar multiple of n, and then I find this vector, which is going to be v minus Tn, and this vector I can also have here, it's going to be the same one. So what I have then is I have the two vectors that I need, this one, and this one in order to calculate this angle. Why? Because the formula that I can use for calculating this angle is going to be cos of theta is going to be the V minus Tn dot V over the norm of V minus Tn multiplied by the norm of V. Right. So firstly, we know we are going to need the vector V. The vector V is simply the vector from A to B. So it's going to be the components of B, 0, 1, 2, minus the components of A. So it's minus minus 9, then it's minus minus 17, and minus minus 25. So that gives us 9, 18, 27. The next thing we know is that the vector V minus Tn is going to be perpendicular or orthogonal to the vector n. Right? So we know that we can say that V minus Tn in brackets dot n is going to give us 0 since they are orthogonal. That means that V dot n has to be equal to T multiplied by n dot n. So that means T is going to be equal to V dot n over n dot n. Right? So it's going to be the components of V multiplied by the components of n. So it's 9 multiplied by 4 plus 18 multiplied by minus 1 plus 27 multiplied by minus 1 all over, and then we're just going to have the components of n squared. So it's 4 squared plus minus 1 squared plus minus 1 squared minus 9 over 18, since we have in our denominator 16 plus 1, which is minus a half. So that means T multiplied by n is going to be minus a half multiplied by n, which is 4 minus 1 minus 1. So we are going to have minus 2, a half, and a half. So we are looking for V minus Tn, which is then going to be, so we have V's components, which is 9, 18, 27, minus Tn, so it's going to be minus minus 2, minus a half, and minus a half. That's going to give us 11, 35 over 2, and 53 over 2. So what we need to do now is we need to use this formula in order to get cos of theta, and then we can solve for theta. So let me just rewrite that. So cos of theta is going to be V minus Tn dot V over the norm of V minus Tn multiplied by the norm of V. So we have V minus Tn, so it's going to take its components, and we're going to take the dot product of that with V, which has components 9, 18, 27. So this is going to be 11 multiplied by 9 plus 35 over 2 multiplied by 18 plus 53 over 2 multiplied by 27. Right? And then it's going to be the norm of v minus tn. So that's going to be the square root of 11 squared plus 35 over 2 squared plus 53 over 2 squared multiplied by the norm of v, which is going to be 9 squared plus 18 squared plus 27 squared. And if I then work out what theta is by taking the inverse of cos of whatever value you get that to be, then you are going to get 3.61 degrees. Please make sure that I did not make a calculation error somewhere, but as long as you understand the process, that is the main thing. This is the end of this week's video.